Why is it needed? We will have two versions. In fact, many more can be created. Let's say another dev version for running the application. In principle, this can also be somewhat related to debugging for running the application by developers, for running the application on the server, like this version, and, for example, for running under debugging pressure.
Do you want to become a cool programmer? Subscribe to our Telegram channel.
So what are these two versions? First, we set everything up, copied everything, installed everything. This is like how we used to write Docker files. To begin with, we will take the existing image as a base and proceed to develop a subsequent production stage that builds upon it. The production stage will be used, such as, for example, to run this application on the server. And, as you can see, here we write the command that will run our application. The application is in the minepy file. Now we also create the next stage from production and call it debug. What is this debug stage? In it, a command is executed that simply prevents the container from stopping. Sleep infinity is just an infinite sleep. We run the container, while the Python application itself does not start in it, as this command will not be executed. Only this one is executed, and the container simply does not stop immediately, because if we do not specify cmd, then this Python 3.10 container will stop right away, as nothing will be executed. In some infinite loop, this command, we essentially do not let the container die, ensuring that the process continues indefinitely. Now, what extension do we need? Remote development is a whole set of extensions. There are 4 of them for remote development. That is, essentially in VS Code we can connect to something remote. WSL. WSL. This is if we are using Windows, Linux subsystem. For example, I am currently on it. This is not particularly needed.
Want to become a great programmer? Subscribe to our Telegram channel.
This allows us to connect to containers and, moreover, essentially deploy VS Code there. And through this interface we can manage VS Code, which is essentially located inside the container. Well, there is also SSH, which is for remote connection via SSH. And tunnels, I believe, is for connecting to virtual machines. So, we have installed dev containers. I already have it installed. Overall, this is everything you need to essentially establish a connection to a running container. And it is also highly desirable and beneficial to install the extensions inside the container in order to allow working with the language. Since we have Python here, we will need extensions for Python, but we don't need that right now. So, what we do is create a Docker file. I also assemble Docker Compose so that I can work with Docker Compose instead of plain Docker, because I prefer it that way. With Docker, you can do exactly the same thing, but you will have to write slightly longer commands instead of this configuration file, and that's all. What is this Docker Compose file? In general, it's standard. You can add some services here if needed. Connect a database, cache, or bring in another application. But we are only interested in one application that we plan to debug.
TFSP.
Build. What do we write? Context Docker file. We covered this in the last lecture. It's done. In other contexts, contexts. Where will all the paths be built from? What Docker file are we using for the build? What is target? Target is target. This is the specific version from the Docker file that will definitely be utilized as the most recent and up-to-date version. During the build, that is, if I set the prod, my Docker file will stop right here. That is, all these instructions will be executed, and as soon as this from prod from debug is reached, they will no longer be executed. We'll stop at this stage. If I, for example, debug here, then the instructions will be executed up to this point. And I will already be at the debug stage. Let's first run it in production mode. See how it behaves. We write the docker compose build command. It was set up because it pulled the images, and we are raising docker compose app 3. We have raised it, and what do we have here? Let's see. Ah, yes. And it is not mainp now. I forgot to write it in rupture. What is here? In rupture source. Here. Docker and desktop, and certainly indeed our Python application has definitely started. Here we can open and hooray! So here is Docker desktop and our Python application has started here. We can open. There is a ping handle there. Let's ping it. It gives a response, meaning the application is working.
TFSP.
Everything is as it should be. This was the production mode, meaning the application just started. We are not going to debug it. Let's say we have already debugged everything. It works stably as it should. We run it on the server and that's it. Now, how exactly do we debug it? Let's move on to the main part of the lecture. For this, we need to change the target here. So, I will kill Docker. Overall, we have confirmed that everything starts as it should. We change the target to 2. Now our Docker file will reach all the way to here. And at this stage, we will stop. We write docker compose build again, just in case docker compose up to. Just in case Docker was crawling there completely. That's it. We stopped at the debug stage. Now let's see what is happening in Docker. There are no logs, as you can see. Well, because our application was not running. And if we write docker compose ps to see which processes are actually running, then the only process running is the sleep infinity command. There is nothing else here. If we go back to prot, let's return now. Docker compose down, docker compose build, docker compose add-in. And if we write docker compose ps in the terminal, we can see that the Python application has started. This command has executed, and it also works in the browser. I refresh, and it shows me docker compose down. If I now set sleep infinity, meaning we change the configuration to debug, then as it was before, the process will only be sleep, and there are no logs. Admin team docker compose ps shows that the sleep infinity command is running. The container just doesn't die. It keeps running. But there are no logs, and the application is also not running. For example, if I refresh here, the page is unavailable because the application is not working. How do we connect to this container? First, we install the div containers extension and click here. Or we can also do it through the command line, fetch to running container, and observe the output to ensure everything is functioning correctly as expected and without any issues in the system. We should also verify the status of the application and its components to confirm proper operation and stability. Here I simply clicked fetch to the currently running container, and here we actually have the only container. If there were more, it would just list all of them here. We will need to choose a specific one to which we want to connect. Since we have only one container, we connect to it. A new window appears on the screen, and a variety of different libraries begin the process of loading, each one preparing to execute its specific functions. Well, more specifically, Xcode is in fact installed in the Xcode server within the container. This is precisely the thing through which all extensions from remote development operate. Essentially, a VS Code server is installed on the remote part, and the VS Code server is, you could say, an application that allows you to remotely deploy VS Code and connect to it. So right now I am already in the Docker container. Here I have the root user, as you can see. This is the hash container displayed here. We can take a look at some slash. I immediately entered the source folder, and I can, for example, find myself in the default root folder somewhere here. I will need to switch to where I want to go, specifically to my project, which is located in the source folder, and here I will have the file main.py. Now, to run this inside the container, that is essentially, all the extensions here are basically divided into local ones, meaning those installed in my VS Code and those extensions that are in the container. Here I have emptiness, essentially, basically. To work with Python or some other language, I need to install the extension accordingly. Well, we take it, for example, install it through search, or here I have the extension inside, and it already suggests installing. We install Python debugger, and the extension pack is not necessary to install. Okay. Oh, I installed Python debugger. I just need to install Python. Oh, and I installed Python. Do we need to restart? Anything there? No, it seems we don't. We now have the option to choose the version of Python. And now we can set breakpoints wherever we want, and just run the debugging in base code. I'm pressing F5. F5 doesn't work. And it will start again. Or should I still restart the handle and load?
Windows. The application debugging has started. From here on, everything proceeds just like in regular VS Code. In fact, this is regular VS Code, which is simply connected to a remote server. That's how it works. Our application hasn't started yet. Oh, Ubicorn run. The application has started, and it is working. So if I actually go to the link, let's not ping, but it already returned something, no error. And since I set a breakpoint here on the ping execution handle, which is a tool used to pause the program execution at a specific point, if I hit ping here, I get a long loading time. This indicates that the debugger, which is a tool for testing and debugging code, has stopped at this point. Well, I can debug something here, allowing me to inspect variables, step through code, and understand the program flow in detail. And there it is, the yellow track, which means it has stopped. If I step forward now, the ping went through. Returned 200 statuses, and it returned here as well. That's it. I repeat once more. This indeed absolutely works with any language. DOL, definitely. That is essentially how we debug in regular Visual Studio Code without connecting to Docker or a remote server. It will look exactly the same when connected to Docker. The only difference is to slightly modify the Docker file, add the debug configuration, and remember to specify in Docker Compose, if we are using it, that we are in debug mode, slightly. This can essentially, in principle, be done in non-volatile memory, NVM. That is, we specifically create it in the kev file. And you can set such a variable in app.runMod. It will be either debug or prod for us. And here we will take this variable from env.app.runMod. To not change Docker Compose specifically, but only the input. Alternatively, we will write prod, and accordingly, it will be in a different location. That's it. Then connect and work as you would on a local machine. Any questions? Well, if there are no questions, then thank you all. That's all for today. Want to become a cool programmer? Subscribe to our Telegram channel.
Hello everyone. We are starting a free open lecture in our Discord. All our lectures are held weekly without breaks. If you, the viewer, want to ask questions online and get answers, join our lectures. You can find the link to Discord in our Telegram channel. To find out the schedule for the lectures, join our Telegram channel. Today there will be a very useful, incredibly insightful, and extremely informative and very short lecture indeed. And today we will talk in detail about how to troubleshoot and debug applications that are running step by step in a Docker container. We will consider this in VS Code, but a similar functionality is available in other environments, for example, JetBrains. But as far as I remember, in JetBrains environments, this functionality is only available in the paid versions. For example, This is not available in PyCharm community. Everything happens for free, and we have some file. Let's say this is a post API application, such as, for instance, written in Python. But this method will also work for any other languages, for which there are extensions that allow you to debug the code. Now, in addition to the existing features, we also have a Docker configuration file. For our application, let's take a look at it. Well, this part is quite standard for a fast API application, meaning we take a base image where we will have Python, install the necessary dependencies, copy the file here, and specify that we need to open port 8000